Our planet is brimming with the beauty of nature, and perhaps the most striking example of such beauty lies in our oceans. Making up 70% of our planet, these tranquil waters harbour unique and wonderful life forms. When we look out upon our oceans, what words do we think of?
Vast.
Exploration.
Expansive.
Vital.
Wilderness.
Our ocean is precious to us all in different ways, but it is in danger. Since the dawn of the Industrial Revolution, we have increased exploitation of our oceans to unprecedented levels, resulting in overfishing, driving loss of biodiversity through bycatch and habitat destruction. Population loss is one thing, but there is a hidden danger. When we capture fish, we often target the largest, most economically valuable fish. And over generations, this results in smaller and smaller fish. Even if we would stop fishing, allowing population numbers to recover, underlying genetic changes may still be present. To understand the effects of overfishing and subsequent recovery, we collected fish from the West Bengal region in India and brought them all the way back to central Finland to the University of Jyväskylä. For this study, I focused on the fish after they had recovered from overfishing, returning to their original population size. I started by removing some muscle tissue from the fish and extracting DNA. Using this DNA, I can look at the underlying genetic structure of the fish before overfishing, after overfishing, and after fishing had been halted, often dubbed a moratorium, where absolutely no fishing is allowed. I could then observe whether their genetic structure changed, and if they continue to change further, even in the absence of any fishing pressure. Beyond that, I examined whether size selection, especially for large fish, influenced how that genetic structure changed. What we found was that all fish returned to their original size. Great, no harm done. But their genetics have changed, which is important for adaptation to other environmental stresses, such as the ravaging force of climate change. Such changes in genetic structure mean some populations won't be able to cope with climate change, however some might, and we found that those experiencing no size selection potentially deal with this tide of climate change. Our results are another piece in the puzzle for helping recover our fisheries and promote more sustainable management, being wary that not only do surface observations matter, but delving deep down to understand what lies beneath is also important. But all is not lost. If we work together and use scientific evidence to support our decisions, we can preserve the fragile tranquility of our planet's greatest feature, the ocean.